All right, we'll go ahead and start. If you still have not checked into on campus, please do that. A couple people still haven't, and a couple people still aren't in the lecture. Um, I honestly don't have a whole lot for you today. I am adding one piece of work to your homework for this weekend, but it's along the same lines. It just has to do with an infinite sum of a geometric sequence as opposed to a finite sum. Okay. So I wanted to go over questions. It doesn't seem like many people have any. I think the one question I got was when the lower limit is changed. Right? So instead of I is equal to 1 here, it's like -3. Okay. And in that case, your first term is a -3. And then you have to change the total number of terms that you're dealing with. Okay. That's really the only difference. We got to be careful about how many terms we're summing together and what our first term is actually going to be. Okay. That's literally it. So instead of Sn is equal to a1, it's a -3. And then we have to be careful about this n, and everything else is the same. Okay. Uh, so I again, I don't have a whole lot for you, so I want to be very deliberate about what we're going to do today. If you have any questions, if you have specific questions from IXL that you just couldn't get, I'll give you a couple minutes. You can screenshot them, you can send them to me, and we can do them on here. Otherwise, if there are no questions in the next like 4 or 5 minutes, I'll end this. I'll start a meeting on Teams, and if you need specific help, I'll help you there. In the infinite sequences, do variables change at all, or do they still have the same definition? Yeah, so in the infinite sequence, right, R is still your common ratio, except in an infinite sequence, this is going to be less than 1. Okay, A1 is still the first term that you're summing together. But yeah, everything else is the same. All right, so we'll do an example together. This is directly from the homework, which is W18. All right, and this, again, this is about infinite geometric sequences. And it says to find the sum of the infinite geometric sequence, write your answer as an integer or a fraction in simplest form. Okay, so the first thing we have to do with all this stuff, with infinite geometric sequences, we don't have to find a rule. We don't have to do anything except find a common ratio. All right, so if our first term is 4, and we have to get to 3 by multiplying by something, the only way to get from 4 to 3 by multiplication is to multiply by 3/4. And if we continue that pattern, we have to multiply 3 by 3/4 to get to 9/4. And again, to get to 27/16. Okay, so again, because this is consistent, we have a geometric sequence. And for our rule, the sum of this sequence just follows this equation. All right, so the sum of this is the first term plus 1 minus the common ratio. All right, and then we have to simplify. So S is equal to 4 over 1/4. Which is really equal to 4 times 4 over 1, which is equal to 16. Okay, so questions over that example. This is the exact same type of stuff that you would see on it. This was from Smart Score like 33. I'll do a couple ones harder, but this is what you'll see. All right, so let's do a couple more. All right, so now we want to find the infinite geometric sequence, or the sum of the infinite geometric sequence, given what you have on your screen. Okay, write your answer as an integer or a fraction in simplest form. So again, in this case, we have to be a little bit more careful because our lower limit is n is equal to 0 instead of n is equal to 1. Okay, so our first term is really our 0 term, which is just equal to 4. And then our common ratio, again, is 3/4. Then if we use our rule, we actually get the same thing. I'm curious to see if this is right. It is. Okay, so questions on that example. So again, when you see something that is not 1, that doesn't necessarily, if it's not 1, you have to find the first term that we're summing. So in this case, the first term that we're summing is actually a 0. All right, again, this example is a lot later. This is 89. Um, we want to find the infinite sum from 3 to infinity of negative 11 ninths times 1/4 to the nth. Okay, and again, we follow the same rules, right? So our first term in this case, though, isn't a1, it's a3. So if we find a3, we'll get our numerator. When we do that, we get negative 11 over 432. Okay, so it's really the same thing over and over. You're just following this equation, but you're being very careful about what your first term that you're summing is actually going to be. Okay, so questions over any of these examples? Okay, if there are no other questions, I will end this in a couple of minutes, and I will head over to Teams. And if you have specific questions or just want to work while I'm in there, uh, I'll start that in a couple of minutes. Okay, so I'll leave this open. General questions here, and then we can work in teams together. I also get that this was like not as organized as it normally is. I honestly just wanted to work on infinite geometric sequences without adding a whole lot because I get that some people might be really confused on this stuff, and I want to make sure that we understand this completely. I am still on grading the videos. I've graded everyone else's tests. I'm just trying to figure out how I want to like divvy up points. That will be in pretty soon. My guess is, from what I can tell, that you guys did really well. I'm just trying to figure out how to like quantify that. All right, so I'll end this. I'll start a meeting on Teams, and if you have questions or just want to work, I will see you there. All right.